Hello everyone. Today we will be solving another new problem. This problem was recently asked in TCS CodeVita round 1 zone 1. The problem statement name is Klaara's Fortress. I'll just quickly go through the problem statement. This is a big problem statement. I'm gonna read through the whole problem statement. So there is a fortress and there is a queen named Klaara, and the fortress has an entrance at 0 comma 0 position, and there is an exit at bottom right, means m minus 1 comma n minus 1 position. There is a thief from the neighboring kingdom. He's trying to steal the jewelry from Queen Clara's fort, and there is a feast going on to the fortress of Queen Clara. So the thief comes along with the guest in that particular day, and the thief gets caught at the entrance of the fortress. So now the thief is trying to escape the fortress. The thief already knows the structure of the fortress, so the thief is trying to exit through the shortest path of the fortress. And Queen Clara came to know about this, and Queen Clara can is has a automatic locking system that will lock a room from every side, and the Queen Clara can only use the this locking system at most once. And there is another constraint given, like we need to find the max time that the thief will take to reach the exit from the entrance to the fortress, considering that Clara can at most block one room, and Clara cannot block the room, which result in no path between entrance and exit. That means that there will always exist a path from start node to end node, and the thief will choose the shortest path to exit. And in the path, the fortress is represented as ones and zeros, means binary matrix, while where one will represent locked room from all the sides, that means upward, right, down, and left, and zero will represent an open room. That means you can go from one room to another room via zero. So basically, I'll just give the problem in the description of the video. You guys can read through the problem statement if you don't understand it. Okay. Now, let's jump to a test case. So this is our constraint. The M and N means the size of the matrix is given as 3 at max. It will be 20, or it is 3 at the lowest, 3 cross 3. The time limit is given as 1, and we need to print the time taken to exit. Yeah. So this is our entrance at 0 comma 0, and this is our exit point at bottom right, means n minus, let's say n minus 1 comma n minus 1 position. Okay. Now the thief will take the shortest path to exit, and there is a automatic locking system which will lock a room from all the sides. That means in the question it is mentioned that 0 means open room and 1 means closed room. So if the locking system is activated, uh, it means that 0 will convert to 1. 0 will get converted to 1. That means that thief cannot take the path. Okay, basically, let's see the shortest part of this matrix. Okay, so the thief goes by this way. Suppose this 0, then this 0, then this 0, then bottom down, then here, then to here, then to here, and finally exit. Okay, so if the thief takes this path, the time taken to exit by the thief will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. Okay, got it. Thief will take 9 minutes, but suppose the automatic locking system is like activated, and in the criteria, the question in the question there is a criteria that you cannot close a room such that there will be no path. So I cannot choose a 0 and convert it to 1 such that I cannot go to n minus bottom right position or the end position. So I need to choose a 0 such that there will always exist more path, greater than one path, basically. So for this test case, I need to close this 0. If I close this room, or I toggle it with 1, that means a thief can go via this path. This to this, to this, to this, and to this, to this. So Now the time taken by the thief will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Yeah, this is the 15. And in the question you can see it is mentioned that 15 is my answer. Got it? The explanation you can see as well that he will need 15 minutes and these are the position, these are the indexes that he will travel through. Okay. Okay. So now we need to think of an intuition first before going through the jumping into our solution. Okay. So if we think brute force, like what we can do, like if we'll traverse through the matrix, and if we find a zero, then we'll do a traversal algorithm like BFS to find all the neighboring zeros. And by this way, we will check if there is a way from 0 comma 0 to n minus 1 comma n minus 1 position. Okay, got it? And at each position, we will try to toggle one. Okay, suppose I am at I comma j position. I will toggle it if it if array of I comma j is 0, we will toggle it to we will convert it to I comma j should be 1. We'll make it 1 and we'll check if there is still a path exist from 0 comma 0 to n minus 1 comma n minus 1 position. If there still exists a path, we will calculate the distance. Okay, we'll calculate the distance and then compare it with the previous distance that we have calculated. I think you didn't. So if I write the algorithm for this, okay, so this should be, let's say for I equal to, let's say 1 to m minus, let's say n minus 1 for j from 1 to m minus 1 position. Okay, now if fort of fort of ij is double equal to 0, that means there is a path. We will make it ij should be 1. Okay, I converted it to 1, then I'll call my BFS function. Let's say that our BFS function will return the distance uh, taken by the thief, or you can say the time taken by the thief to start from starting node and reach end node. So our distance should be BFS, let's say BFS of ij, or you can say 0 comma 0 to n comma m, not ij, because I need to check from the starting node to the ending node each time. Okay. Now, at the answer variable, we will just calculate the max value of distance and answer. Okay. And we will finally make our fort of ij 0 again. Why? Because it may happen that if we convert our fort, if we convert it to 1, there might not exist any path. For suppose if we convert this 0 or this 0 to 1, there will exist no path, right? There will be no paths to reach the end node. So that's why we'll need to again make it 0 to check if there exists another path from that node. That means basically before the junction point, if so for this test case, this is the junction point because there are two paths from this junction. And before that, we cannot toggle any 0. Okay, so this is straightforward pretty much. In the question, the constraint are given as m comma n as less than equal to 20, and the time limit is given as 1 second. So this solution should take around okay. These two nested for loop will cross n cross m times running, and the BFS function will also uh, another n cross m time will run. So I'm doing the BFS function will n cross m times basically. So this is for BFS and this is for our the nested loop, two loops. So this is our big of n cross m square. This should be around, okay, 20 into 20 means 20 into 20 square means big of 400 square means which is equivalent to big of 2 to the power 4 into 10 to the power 4, which is also less than 10 to the power 9, right? 2 to the power 4 into 10 to the power 4 is less than 10 to the power 1. That means this solution will run under 1 second. Okay, so we can move forward with this solution, I believe. Okay. So now, what should our BFS function will look like? BFS function will have parameters ij, the fortress, the value matrix itself, the n and m, the size of the fortress. Okay. So any standard BFS will go. We need to have a queue for any standard BFS algorithm. Queue of pair because it is a matrix intent. We need to have a distance vector. So let's say distance vector of n comma m, size of n, size m, n cross m. Okay, my bad. Anyway, and we need to have a visitor die. Okay, so let's make it bull visited of n m, right? All should be false at begin. Okay, now standard BFS algorithm will need to check the uh, we will first push the ith and jth node, I comma jth node, basically. So q dot push I comma j, mark it as visited. Then while our queue is not empty, we will check the adjacent nodes. Now for adjacent node, what we need to check? Suppose we are at a index x comma y. Adjacent means right, down, left and bottom, left and up, sorry. So changes in terms of x and y should be x plus 1 comma y at right, x comma y minus 1 at bottom, x comma y plus 1 at up, and x minus 1 comma y at left. So our d row vector should be, or d row array should be um, changes in terms of indexes, right? So this should be 0 1 0 minus 1. D column should be 1 0 minus 1 0. Okay, so our then we will extract the in the while loop we'll extract the top element of the queue, or you say front element of the queue. So let's say row should be equal to q dot front dot first. Same goes for call equal to q dot front dot second. And now we'll check the adjacent node for this node, row comma call. So we'll run a loop through from I from 1 till 4. Okay, then we'll check our new row. New row should be row plus d row of I. New column should be column plus d column of I. Then we will check just this new row and new column is inside the matrix or not. So if our new row, okay, let's write it like this. If new row is in the matrix, means 0 less than equal to new row less than n, and 0 less than equal to n call less than m, and it is not visited. That means not visited. So visited of n row, n call is true. It will give true, and in that in end row comma end call position there is a 0. That means we can traverse through. And the fourth of end row comma end call is 0. That means this if this statement holds, then we can basically q dot push q dot push will be let's see, q dot push n row comma n call. Now we need to add the distance in our distance vector. So distance of n row n call, distance of n row n call should be distance of row call plus 1. Okay. Since it will take 1 minute to go from one node to another node, it will take 1 minute of extra time. So this is why plus 1. And finally, we will mark it as visited, end row, end call. Now finally, we will return in our main function. There is a answer variable that we have taken, and the answer variable will have the answer. We will return that answer plus 1. Basically. So this will be our answer. This runs in a big of n cross m whole square time. This solution. If you have a better solution, you can always mention it in the comment. Okay, so let's declare the size of the matrix first. Cn m. Let's there will be an vector of vector n, fourth of size n cross n. Okay, this should be fourth for n. Let's take the input. Now I will iterate over the fourth matrix basically. For n I equal to 0, I less than n, I plus plus. For int j equals 0 and j less than n, j plus plus. Okay. So now we will check if our fourth of ij is 0. That means there is a path. Okay. So this should not be from 0. This should be from 1 till n minus 1 with position basically. Same for this. Because we don't want to uh, toggle our first and last index, basically first and last position of the, basically we don't want to toggle the start and end of the matrix. That's why we'll start from 1 till n minus 1 and m minus 1. Okay. So now if it is 0, then we will put of ij should be let's make it 1. Then we have a distance variable which will return back from our BFS function. So BFS of 0 0 is our starting index, nm which is our size of the array or matrix, and our matrix itself. Okay, so there will be a variable answer. Let's make it as 0 first. Answer will have maximum values of all BFS faults. So maximum value of test, comma, answer. Okay, and we'll finally make our port of ij again 0, and we will print our answer plus 1. Okay, now let's move to our BFS function. So int BFS int x value, int y value, int n, int n, and our port vector of vector end by reference port. That's it. Now we need to have a queue of pair of int comma int queue. Then we need a distance vector of vector int. This is vector of vector int port and of port distance of n cross n, again n comma starting as 0 for all the distances at first. Then we need a visited array vector of vector bull visited same size n cross n vector of bull n comma false. Okay, now we'll push the first node that is getting passed into the function. So x comma y, mark it as visited of x y is true. Now we will iterate over the queue. Well, our queue is not empty. Queue dot empty. We will find our row value and column value, which is the front or top node of the queue. So queue dot front dot first column value should be queue dot front dot second. Then I need to port the queue. Then I will check the neighboring nodes of this node. So to on the neighboring node, we need to have the d row and d column vectors. So vector of n d row should be okay. So 0, 1, 0, -1, since we are going clockwise starting from top position. Vector of n d call should be let's say 1, 0, -1, 0. Okay. Now I need a loop to check all the sites. I less than 4, I plus plus. Now int new row should be row plus d row of I. Same goes for t call and new call. And call should be call plus d call of I. And if this is under, now I have to check whether this n row comma n call position is in the matrix itself. So n row should be greater than equal to 0 and n row should be less than n, and n call should be greater than equal to 0 and n call should be less than n, and it is not visited. So visited of n row n call should not be visited, and I need to check if there is a 0 at that position. N row port of n row comma n call should be 0. Then I will push it into our queue. N row comma n call. Okay. Then I'll calculate the distance of n row n call should be distance of row call plus 1. Since traveling from a node to its adjacent node will always take 1 minute of time, that's why we're adding 1, and then I'll mark it as visited. And the row and call should be true. Okay, then I will uh, outside the queue loop, and I will return our distance of the last node. n minus 1, n minus 1. Yeah, I think it's pretty much, we're good to go. Let's see if it is working or not. So this is our test case. The answer should be 15 for, yeah, let's see. Yeah, it's coming as 15. Let's see another test case. This is the second test case. The answer is 9. Yeah, yeah, it's working. So this is our intuition code and approach for this solution. And this solution got accepted during the contest because there is no, this question is not available on, I don't know if it is available on the internet right now. And I would have go through a platform to submit this code. Yeah, that's pretty much the solution. Thank you for watching. Let's meet on another video.